Okay, let's go to check other hydraulic outputs. First of all, I'm going to GIS tools, RAS Mapper, and I want to show the usability and the potential of RAS Mapper environment to capturing the hydraulic outputs. Okay, you can go to the results section and check this part and go and check the hydraulic output, for example, depth, velocity, and water surface elevation for specific or for all discharge values. I select depth, and you can see the spatial distribution of depth for your study area. You can uncheck MyGeo to see only the hydraulic outputs. For example, this is for Q with the return period of 10 years. You can click and select this layer and right click on that and select edit map parameter. Okay, in this result map parameter, you can select your desired discharge values. For example, I select Q100 and save the map. You know, the water depth is completely different with that discharge value. When you're crossing on the depth raster, you can see the depth value, and this is the legend, and you can uncheck the train to see only flood depths through the river. You know, the values are in meter format. Also, you can use Google Earth maps in the background to better representation of your results. In map layers, you should right click on this section and select web imagery layers. And in this figure, you should select your suitable map. Some are for ArcGIS database and some for Google Map, Google Hybrid, Google Train, or USGS imagery or USGS topo. If you are living in European countries or United States of America, you can use USGS imagery or OpenStreetMaps and other ArcGIS datasets. But in this section, I want to use Google Satellite to present our hydraulic properties. Okay, I select Google Satellite. You should be aware that your internet connection must be good to load Google Earth image in your RAS mapper. Without internet, you can access to the Google Earth maps. Okay, select OK and select the map layers. Please be more patient when you are loading Google Earth or other online image in HECRAS. Okay, you can see the Google Earth in the background, and this is the distribution of flood depths through the river. Okay, you can decrease the transparency of this layer. Right click on this layer and select layer properties, and you can use the lower transparency to better see the rivers. Okay, or use other color ramp or other settings for your layer. Also, you can use discrete format. For example, I want to discrete the depth into 5 class, apply. Okay, you can see. However, I think this stretch format is the better for this case. Okay, you know, this remotely sensed them is completely okay for flood inundation mapping. However, that needs a little bit modification with the ground control points. Okay, the velocity for higher discharge values. Okay, also you can use, I think particle tracing to better representation of flow vectors and the direction of flows through the study area. Okay, in the velocity setting, you can change the velocity of speed, density, and other parameters of flow vectors, density, and other, or spacing. This is a completely graphical icon for better representation of flowing of water or flood through a case study. Okay, you can uncheck that and it will be removed. Also, you can use a static velocity arrow to present the velocity vectors, and therefore you can change the spacing, also the color, white or black, or other spacing size. Okay, and this option is suitable for meandering or rivers with the wide floodplain sections. Moreover, you can use water surface elevation for higher return period. You can also save the outputs in raster format or vector format. For example, I want to save this layer, this raster layer, and open it in Google Earth or in ArcGIS environment. Right click on depths and go to the edit map parameter. In the edit map parameter, you should check the raster based on train options and select the save map. Okay, you should right click on this layer and select compute update stored map. Okay, you know this icon means that the layer is completely saved in the computer or in the desired direction or folder. Also, you can do this issue for different outputs and check the raster base, save, and do other processes. Okay, one of the best outputs of HECRAS in RAS Mapper is the selection of other hydraulic important parameters. For example, you can show the inundation boundary in shapefile or vector format, depths, shear stress, depths multiply velocity, which is important output for flood damage analysis or flood damage studies, depths in flood multiply velocity power 2 and stream power. Let me check depth velocity. Select press and you can see the value of depth multiply velocity. Okay, let me to load Google Earth picture. Okay, you know the value is ranging between 0 to 10. The legend is for previous layer and you should change the value of this parameter. Therefore, I should click on layer properties, go to the edit, and in maximum, you should select, for example, 10. Create, apply. Okay, now you can see better representation of these outputs. It means that when the color is red, that means this area is the dangerous part of the river, and when you see the green colors, that means this area is completely safe when the flood is crossing. Okay, you can use the discrete method to better representation of the dangerous and high dangerous and safe zone. Okay, this output is one of the best important features of a newer version of HECRAS. Okay, you can see we did all required steps in RAS Mapper, and finally you can use other map type or output. I select inundation boundary. It creates a shapefile or vector format of selected flood inundation extent. Okay, in this step, you should select, right click on the layer and select compute update stored map. Okay, now you can see a vector format of flood extent for 100 return period of flood. Also, you can right click and export layer into shapefile or KML and open it in Google Earth environment or open it in ArcGIS or other similar GIS environment. Okay, I select shapefile and in paper I name it WSE underline X extend sat 100, excuse me. Okay, it's created successfully. You should go to the ArcGIS, select add data, come on man. Okay, select WSE extend, select add. Okay, you can see a shapefile, which means the flood extent, and change the color. Okay, this is the flood maps. This small area is due to the remote sensing and raw DEMs, and that means you should correct or modify your DEMs before using flood inundation mapping. And if you correct and modify your DEM using ground control point, you can create a better flood maps with the better shape for your case study. However, I think it's good for this example. Okay, I think there isn't any explanation for this environment. Close the RAS Mapper environment and you can go for other section and go and see the water surface flood extent through the river for different flow discharges. And you can use this section to representation of 3D representation of flood extent. And this is the variation of flood hydraulic properties through the or along the rivers. You can select velocity, right click on the window, select profile, clear all, and select only one of them. And also right click on the window, select plot variables, clear all, and go down and select velocity total. which means that the mean average velocity in each cross section. Okay, you can see the variation of mean velocity for each cross section through the river. At the upstream, the velocity is higher because the slope is higher, and in the downslope, due to the decreasing the slope value, the velocity tends to decrease. And you can select other, for example, top widths. Right click, plot variable, and select only top widths. Excuse me, plot variable. Okay, in this figure, you can use different variables and show the variation of hydraulic properties through the river. For example, I want to plot hydraulic depths. Okay, you know, at the upstream, the hydraulic depth is lower, and in the downstream, the hydraulic depth is higher because the slope is lower in downstream and is higher in upstream. Okay, for again, plot variable, go down, and you can select, for example, fruit number for each cross section. This is the variation of fruit number. You know, in most cross section, the flow type is subcritical, and we don't have supercritical cross sections. Okay, this is main channel distance and profile plot. In table section, you can see different discharge value and different hydraulic properties. As I mentioned before, you can go to option menus and select define table and delete all default columns and select only your desired output. For example, I want to plot or create only velocity or other hydraulic parameters. For example, fruit number for cross section, select the next column, select hydraulic depths. In fourth column, select hydraulic other radius. It's not so important. We can select power or other hydraulic parameters. There are different outputs for the right bank, left bank, total cross section, only main channel, and which of them you can use and show at the output. For example, shear stress total, top width for cross section, total velocity, and finally, okay, I think this is enough. Okay, I press OK, and you can see a summarized output and for each cross section, and for profile you can see the hydraulic parameters. Moreover, you can go to options and click profiles and select all discharge value and the model sort the results from the upstream to downstream. You can click copy clipboard to data and headings, copy clipboard data only, or print it in picture or PDF format and write that to a text file and open in Notepad or WordPad or other environment. For example, I can use this option, okay. Select Excel or Office or other spreadsheet environment and paste the output and refine the results to better representation in your reports or your papers or your studies. Come on, Office, come on. Okay, I create a new sheet and right click on that and select paste. Okay, you can see the output. Excuse me. Okay, you can remove the unrelated or unnecessary columns. For example, this is okay. You can create borders and copy that and go to the Word environment and paste that in that environment. I do that for your better guidance in your studies. Come on, Office. Okay, in the paste menu, select paste special and select picture enhance metafile. Okay, you can see the output is completely in picture format, and you can easily drag and drop or decrease the dimension of pictures and store that. Okay. Okay, I think this is just enough for flood inundation mapping using RAS Mapper. There is no different in type of DEM. You can use SRTM, you can use ALOS, you can use the ground-based DEM. The processes is or the steps is completely the same. And if you can do for ALOS DEM this process, you can do that for different rivers, for different DEM sources and different data sets. Okay, I think this part must be finished, and in the next part I should talk about some the usability and some modification of remotely sensed DEMs for your case studies and river engineering projects. Okay, have a good time and happy river engineering modeling.